Hello, and welcome to our webinar on Next Generation Interfaces, the fourth episode of Nemertes' Emerging Technologies Research Series. I'm John Burke, Nemertes CTO, and presenting with me today is Nemertes Research Fellow Marc Seybold. He's a former CIO of SUNY at Old Westbury and past chair of the SUNY Council of CIOs. We'd like to encourage everyone to submit any questions you have along the way. We might be able to address them right away, and we'll certainly save time at the end for questions and answers. We'll answer as many questions as we can. With that, let's go ahead and get started. And here I am.
Thanks, John. Welcome to all the attendees.
There we go. Let's get started. So we're here today to talk about next generation interfaces. And Marc, I'm sorry.
That's okay. This is definitely one of the fun topics. A lot of these things are a bit dry, but this one has some nice entertainment value. So we started off with a famous quote from Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from magic. And some of these things are looking pretty magical. So what's really driving the advances? It comes down to the display technology. Microleds have had some substantial breakthroughs in the last few years. They've been able to push them up to about 8K resolution. And originally it looked like that was only going to be possible for things like Oculus type displays, but it turns out that they figured out how to do it for small projectors. So even the AR glasses that are in the pipeline are going to be giving us that. There's also almost unlimited displays. We've seen some of those things from Samsung that are tiled, and essentially you can make them as big as you can figure out how to supply the electricity to them. Some of them are enormous, size of the entire building walls. Rollables have been around for a while, but now we're seeing them in the telephones, so that's starting to come out. Of course, LG's had rollable TV for a while. Transparent, anybody that's been watching some of them, the Korean shows on Netflix, you might have noticed that they had fairly large transparent displays. Those aren't Hollywood special effects, they're actual real displays. We don't see too much of them in the US, but they are floating around in the Far East. There's an absolute flood of glasses coming. A number of OEMs have extremely high resolution displays, and that makes it possible for just about anybody to get into the game. Sci-fi contact lenses, this has been a staple for decades in novels and television, but there's a company called Mojo Vision, which some of you might have heard of. It's actually very close to getting these things to the commercial market. They might have actually excuse me, been able to move it up to about 2 years from now. And the initial target is going to be for the visually impaired. But the idea is that once they're certified, to be able to push them out into a general market. Some big breakthroughs in visualization also. There's been some fundamental advances on the ability to get ray tracing down to the kind of power and size budget that makes it practical for portable devices. And so we're going to see real-time imagery that's almost indistinguishable from something that's reality. And mate that to the 8K displays, and life is about to get very interesting. Deep learning is inevitably going to be a part of this, both to make the things that are synthetic in some manner intelligent and active, so that they're not simply passive devices, but also the ability to learn. Most of these glasses and display technologies have some kind of forward-facing cameras, so the amount of raw data that's going to be available for the deep learning algorithms is enormous, and we're bound to see interesting things come out of that. Some probably negative, but also hopefully a lot of positive ones. So the next generation displays, we talked a little bit about that just now. They're much brighter than the original LCD displays. The pixel counts are at the point where they're equal to or greater than what the human eye can see. So that means that the pixelization goes away, no more screen door type effects, those kinds of things. There's also a lot of work that's been devoted to trying to figure out how to maintain super sharp resolution only in the sharpest part of the human eye, as opposed to having to update the entire display. So it's likely that we're going to be very impressed by these systems.
Is there likely to be any kind of similar phenomenon on the visual side as we've seen on the audio side, where people have turned back to vinyl in some cases to get a warmer sound than they can get with digital technologies, even though digital sampling is often pushed past the threshold discrimination of the human ear, both in recording and in playback. So it's essentially got more audio pixels than the human eye or than the human ear has, in the same way that these displays are going to have more video pixels than the human eye has. But do you think we'll see some kind of similar distinguishability in the quality of what you're seeing? Like it'll look too real or too sharp?
I think given the variability in human vision, that's probably going to be the dominating factor in that rather than the display technologies themselves. I thought you were going in a different direction, though. The classic problem of motion sickness, and especially with augmented reality, where objects are not going to behave exactly as you expect them to, that may wind up pushing people away from doing a lot of photorealism. From a technologist's point of view, making it indistinguishable from something that's real is a goal, right? Or I'm emphasizing a goal. But it may turn out that in practice, that makes people sick, that their visual system is going to constantly be realizing this thing isn't real, and it'll either give them headaches or it'll induce some kind of motion sickness. And I think that once these things are out in very widespread use, we may see a fallback to where the initial displays are very graphic oriented. And in practice, people, or too many people, will wind up having negative physical responses to that. And that we might see a lot of text displays, that it'll have to be some sweet spot where people can actually wear these things for extended periods of time, meaning at the very least the length of something like a Zoom call, so say 45 minutes to an hour at a time, and not have a killer headache or feel nauseous by the time it's over. That's definitely something that's going to be there. We've seen it already with the existing technologies, and that was true even for the most primitive ones going back 20 or 30 years ago. And it's a problem that they're constantly working on, but it'll be interesting to see what happens when it becomes really widespread.
And the other thing, I noticed that you flagged lower power consumption for micro LEDs, and with glasses, you can envision potentially batteries, but not with contact lenses. So are we to assume that they're going to be powered parasitically by body heat or something else?
Good question. Absolutely, they're going to be powered, are being powered parasitically. As far as I can see, they're actually using the RF signals because they're wireless. That's how the systems are being, they're communicating back and forth. And what I think is happening is that they're picking up parasitic RF energy from either the Bluetooth or the Wi-Fi, but I think it's a Bluetooth technology that they're using. Very good point, though. And obviously that comes into some of the safety issues, because the last thing you want to do is heat up the eye. So that's one of the reasons why they're starting out as an FDA approval process, as opposed to trying to bypass that. And inevitably, if these things do work, we're going to see a deprecation of displays. It's kind of interesting. I mean, an enormous amount of time and energy has been put in over the years to create really spectacular flat panel displays. And we may be coming to the end of that era where these things gradually go away. Certainly for handheld devices like cell phones, it's kind of hard to imagine that once the AR glasses are perfected and economical, that you would still have much of a display. Just doesn't make sense from a weight, power, size, all those kind of things. Just devote it to the battery. Give us a bigger battery. Ultra wideband is definitely a factor in all of this, because you've got enormous bandwidth requirements, and most people aren't going to want to have a tethered set of glasses. So there's got to be some kind of wireless communication that's going back and forth with the very, very high speeds.
I don't know, wired earbuds are making a comeback as a social statement.
Yeah, it's interesting. And again, this is probably going to be trade-offs. Devices in the beginning that are battery powered are unlikely to have very extended life, no matter how many hoops the companies jump through. It's going to be difficult to get around that. So we're probably going to see both. I think it's the very beginning of this, and inevitably people are going to try all different things and then see what works.
Absolutely. Now, I think we have queued up here the video of the
Yes.
Mojo Vision
Do.
demo, because that's worth seeing. So good. All right. And let's make it
So
roll.
good. And what you're seeing is their initial take, which is for the visually impaired. So they're giving people highlights of what's around them.
Yeah, it's a good touch at the beginning. She's not taking her cane with her. Yeah.
Yeah. And I believe one of the founders' immediate family is visually impaired, and that's part of what drove them to create the technology.
So the other use case they're highlighting, which is going to have to follow FDA general approval.
Correct. And this is the thing that's been more talked about, though it's going to come probably well after the medical prosthetic side of it.
Yep. Yep. Gosh, just imagine a contact lens that could adjust as your prescription needs adjusted, as you age and your eye changes shape, or if you've got a degenerative eye condition and it changes shape, it could automatically compensate.
That's the promise of this technology. Yeah.
Pretty fantastic. All right, we're going to stop sharing and go back to slides because everybody loves slides.
Death by PowerPoint.
Life by PowerPoint in this case.
So we talked a little bit about the ray tracing. Neuromorphic chips are kind of interesting because the Magic Leap people had done some research work and published papers on actually training neural nets to do many of the visual transformations, so that as you're, say, panning across a visual field, that instead of having to do it as raw calculations, the neural net itself would have been trained to be able to do those manipulations. So that it's going to be interesting to see what falls out of that as these things are commercialized. How much of it is just raw computation and how much of it is being fed through neural nets and neuromorphic chips to be able to do those transformations, and what kind of options that opens up that people can't really imagine when they're only thinking about straight computational transforms. Time of flight cameras are really interesting. Those things started out with the iPhone to be able to improve the visual face recognition for being able to securely unlock it. But it turns out that they solve a key problem for the AR glasses, and that's being able to properly position things on a surface. So anybody that's seen demos from HoloLens or Magic Leap or a number of others, has probably noticed this problem. You'll have something that looks either photorealistic or is completely artificial, and it's supposed to be sitting on a tabletop, but instead it's either floating a few inches above it or it sinks halfway through the table. And that's the problem the time of flight can solve, because it essentially allows you to create a wireframe or a mesh of everything that's in the space. And so instantaneously, the system computationally is able to know exactly where a surface is and properly place it. And it buys you some other interesting things, because if you've got a full mesh, right? So now these are just texture maps from the point of view of computer graphics. So it's possible to instantaneously change that, so that the trivial apps that you've seen for AR, where people are doing room designs or layouts, interior design, basically, this makes it trivial to change the colors of the wall or the windows or the furniture. It also opens up an interesting possibility if you're in some kind of conference call where people could have a visual instantiation of something, and you either look at it and walk around, or if it's small enough, you pick it up and you manipulate it through all three rotations so that the system can build an actual model of it. Now, on the fly, that thing is available for virtual manipulation by the other people inside the room. And if you take that a step forward, depending on what it is, they might be able to alter it in real time, right? Kind of like a live version of Blender or the CAD/CAM programs. And now all of a sudden you could print it 3D if it's an actual object that people were interested in.
Yeah.
Um,
Can you explain the term time of flight?
So time of flight means basically like the LiDAR or the radar systems. It's a radar using light. So the time of flight cameras are basically measuring how long it takes for a photon to come back to a particular pixel. So you can get
So it's
very
bouncing
accurate
something off. Okay.
dimensional data from things. Yeah.
Yeah. Great.
Um,
Let me see. Oh, yeah.
So this is Avangard, and I might be mispronouncing their name. They're an OEM that actually sells the projectors, and so they made a set of glasses as a demo so that OEMs would have some sense for what the things would look like at the end. And I don't know if we have a picture of the projector, but there's nothing next to it, so you can't really see. It's in the upper right-hand corner of the displays. It's in the temples. It's very, very small. And the next display gives you a sense of what it looks like to go through the glasses. So these aren't fake renders. This is actually what you would see if you were looking through them. And you can see that some of the images are clearly easily seen as not real, right? They didn't want to go all the way on the quality of the rendering. But then others look photorealistic. The one in the middle and the lower side of it. You see some of the medical applications. I mean, a lot of these things are going to be niche applications, but they'll be transformational in those niches. So right now, let's say that you have MRI or CAT scan data. These things can be reassembled into three-dimensional displays, but right now they're usually seen on a flat display. And that makes it fairly difficult for surgeons to figure out where is it that the real problem is, or to be able to perceive if you're getting this data in real time, because some of the imaging technology can actually make movies. So now it's possible to rotate this around and you can see what's actually wrong. Maybe it's a problem with the heart valve, or it's a clog in a certain part of the aorta, or maybe a part of the muscle tissue is damaged. So this is transformational, especially that you can see it during the surgeries. I mean, that's pretty amazing. You'll have this. Obviously, the person's not going to be in some kind of scanner during surgery, but as the surgeon is actually performing the operation, the ability to see this and manipulate so that they can match up what they're doing physically with the actual damage or injury, again, it's going to be transformational.
It is. It's so hard to keep a running three-dimensional picture of what's inside the body going when you're only able to see one face of it. And so, yeah, I think it will be in surgical applications, especially utterly transformational to be able to see the whole thing in real time.
Yeah. And you do get a sense like these will be three-dimensional images. The image in the lower right-hand side is giving an example of the light field effect, which a whole number of companies besides Magic Leap are relying on for that. But so these things will have depth. It's not like you're going to see a 2D cartoon floating in front of you.
So I felt the need as a public service to throw in a cautionary note, as I believe it was Andy Finkel there, who was with Commodore back in the Amiga days, said any sufficiently advanced technology is indistinguishable from a rigged demo. So we're not showing actual devices in use in actual field situations. Currently, we're showing demo materials from various vendors, alighting the possibilities of what these technologies we hope and expect will bring to bear in the real world in the coming couple of years. But always a cautionary note, good to keep in mind.
Oh yeah, and Magic Leap is the poster child for that. You know, they went out and had a Hollywood special effects department create their original demo reels, and you know, conveniently left that detail out.
Yeah, small detail.
Yeah. Which brings us to Light Field Labs. This is probably the biggest wow of the things we've got. This requires no glasses. This will give you 3D displays simply by looking at the display walls or in chart tables, or in some cases, a literal building side. I think we're going to go ahead and tee that up.
Yeah, let me roll that video.
Gives a whole new meaning to CAD CAM. That's a building. Again, these are renders, so we don't know for sure what the real thing will look like. But that's like a Times Square billboard size display. Jurassic Park, the museum version.
Screaming children everywhere.
Yes. And the wow. This is one everybody says, I want one of these when they see this.
So this is just a wall space.
This is just a wall-size display. Yep. It's tiled, obviously.
Yep. Very cool.
Now, again, it's easy to do really slick-looking demos and videos because you've got to kind of ask where was the camera placed that was showing the woman on the other side. But it gives a sense of the possibilities of these different display technologies, and whether they're around the corner or a decade out is probably the bigger question. Along with something we didn't talk too much about, most of these things are probably not going to do so well outside in bright sunlight. That's been true for everything that came before, and it's probably not going to change for these. And part of it's a safety issue. You're imaging the eye directly, so there is a limit on how much power you can put out and not have to worry about injury there.
So you might have to wear sunglasses with your contacts that are displaying things for you?
Don't know. That's a good question. It's all those kinds of things are going to only come out once a lot of people are using them. I mean, it begs the question of what happens if you've got the AR glasses and you put some clip-on sunglasses on top of that. Do things get better or worse? And does it make any difference if you're polarizing? Will that fight the image displays? So there are many, many questions that we're only going to get the answers to once you start selling, these things in the millions, and people begin to come back and say, hey, this doesn't work. You've got to change this and that. And why do the colors look so different for me than they do for somebody else? All those kinds of things, along with prescription glasses. Yeah. So here we get a little bit away from the actual displays themselves and ask the question, if you're not doing two-dimensional flat slides anymore, what do presentations start looking like? Are they simply going to be three-dimensional versions of what people put on a PowerPoint slide today? Or do we wind up moving totally away and essentially build virtual models of whatever it is we want to discuss or the information that we want to get across to somebody, and then the presentation is actually being able to possibly walk around or certainly manipulate the models, twiddle dials on it, see what these things do, and hopefully the interfaces are completely not subliminal, but they're not explicit. They simply, you naturally manipulate this environment. There doesn't have to be any kind of training or thought into that. And for that to happen, it's kind of, to me, the analogy with when the Lumiere brothers first invented moving pictures, and I guess it was the late 1880s or so. At the beginning of this, all they would do is they'd find the best seat in the house in a playhouse, right? And then they would plop the camera there and it wouldn't move. They would simply shoot the play as it was done if a live audience was there. And it actually took a couple of decades for people to realize that, we can move the camera. It doesn't actually have to stay in one place. And to be able to start to also say, we're going to edit this film anyway. It's going to be spliced together because the early film reels were very short. So it took a lot of film to get even a little movie. So we don't even have to shoot these things in the sequence that they were done originally as a play would. And only over time, people began to take real advantage of what it was possible to do when you weren't standing there in front of a live audience having to have a linear presentation. And so the question for people that create the presentations in an AR world is, we're at the ground zero point. We're here sitting there saying, okay, we're going to start by just taking the things that we've already got because that's what we know how to do and it's what we're used to. And we're just going to put them up on these displays. So to me, maybe the most interesting thing isn't the technology behind the displays, but how does it change the way we're going to present information? And education, which is the background that I come out of. I spent a career in higher ed. That's maybe going to be the leader in this because they're the ones with the most incentive, and it'll span the entire age range from kindergarten through higher education. But it's interesting to begin to think about how can you present information in a way where people learn by manipulating things that normally they wouldn't be given access to, either because they're too dangerous or too big, or just not practical to have a lot of people be given access to it. And that will inevitably move out into the commercial sector. And it's going to be interesting to see how that plays out. Because we
It is. I
definitely
mean,
just
imagine
go ahead.
People spend a lot of time training their memories, using that memory palace model to try and associate things with specific physical objects, which are in a specific physical layout in space. And if you could take that and reify it, make it a real thing that you or other people could walk through visually and see in a three-dimensional in a fully three-dimensional way, so that in addition to being able to see the surfaces of things, you'd know that if you reached off to the right, you'd find the thing you stuck over there to remind you about that one point you wanted to cover about human rights in this particular context, or other things that allow you to take advantage of spatial relationships and not just spatial dimensionality, if you will. So not just looking at a 3D object, but being able to arrange them in space in 3 dimensions as well, and to move through that.
That's a great point, John, because from a neurobiology point of view, we have place and mapping neurons that are key to how we actually navigate through spaces, whether interior or exterior. And it's long been known as a memorization trick to imagine that the things you're trying to memorize are in some physical space and you're walking through that, and that's how you key those memories. And why all those tricks where you see people memorizing crazy amounts of information in a short period of time, they're relying on bindings to those place and mapping neurons. And so you just gave a really great example of how people should start to rethink the way they convey information, and especially if what they want is for people to remember particular bits of information.
I can't remember if that goes back to Demosthenes or not, but yeah, the memory palace is a very old and well-respected construct.
Yeah.
Anyway, so yeah.
No, I was going to say, go ahead. So we've just actually been talking about this, the idea that information transfer is going to shift away from these static 2D presentations to something that's much more dynamic and may look like actual models. And again, AI and deep learning is likely to play a part in this. And hopefully it's not going to turn into something like the movies and Agent Smith. That'd be a little bit scary there. Pops up all over the place when not wanted. It definitely brings up the possibility of cobots as knowledge workers. Something that imagine a combination of OpenMind's GPT-3, the natural language processor that's behind a lot of the tools that you're seeing on the market. And I don't know if we're flipping back.
OpenAI's GPT-3, right?
Yep.
Yeah. Sorry, I'm going to jump back. I just wanted to point out it's on the slides later, guys.
Yep, if anybody needs to look it up. So imagine things are combinations of that and Google search and domain-specific knowledge. They're not necessarily around the corner, or if they are, they'll be crude first cuts at it. But people can start to think about that. To dredge up some ancient thing. I think Microsoft at one point ages ago had something called Clippy.
Oh God, yes. One of the most hated objects in the world.
So that was just slightly ahead of its time. And if you go much further back in time, I think it was John Scully, and now you're really going back decades, but Apple, and it's still floating around on the internet because I looked it up a few days ago, so it's out there. They'd done a video of something that they called a knowledge navigator. And in there, one of the things they had was what we would call a knowledge worker cobot today. I think back then they just called it a smart agent or something like that. But it was a visual instantiation. Actually, they had an actor that represented the face for it. But it did the kinds of things that you can imagine being possible today. And again, as people start to use these things, they'll go in directions that nobody anticipated. It's one of the things that makes this an exciting field. It's wide open, and there is no natural level of water to find its spot right now. You know, it's a giant, uneven, constantly shifting, dynamically changing landscape, and we're about to find out what the beginning of that journey looks like.
That's what
So
makes it
world
so
building.
exciting.
Go ahead.
I said that's what makes it so exciting.
Yeah. Now, as we were talking a little bit about the beginning, a lot of these topics are pretty dry, but this one isn't. You can kind of get excited about this stuff. So a lot of people are familiar with Unity and Unreal, which are the dominant engines that are out there for creating 3D worlds. They're used extensively by Hollywood, and just about all commercial games are sitting underneath those things. There's also an open source package called Godot. And it's interesting, not simply because it's free. Unity and Unreal, depending on how you're using it, also have kind of freemium models that people can get started with. But the Godot's interesting thing is its barrier to entry is really low. So the learning curve is not super steep to get started with it. And that means that people could use it to start to explore these ideas of, so what does it look like to do a non-2D, non-linear presentation? Something where people can actually wander around. And it's got the ability to put them out for the various handheld devices too, so it's not strictly a desktop utility. And I don't think they have a web-based one, but they can export it so it'll run on Windows, Mac, iOS, and Android. So if somebody wants to start to kick the tires and they're not really interested in the skills development of the package itself, because it's too early really for that, that's another place where you're going to see things evolve very quickly. And obviously Microsoft and Google are not going to sit back and watch their PowerPoint and slides products just fall apart. But this is interesting for people that want to just get a sense of, you know what, how do I rethink my presentations? And a low barrier on the learning side. And of course, it's cost-free. So there's no need to go through purchasing or pull out the credit card or anything like that. And those core skills will transfer. It's kind of like, did it really make a difference whether the people knew how to use Lumiere's cameras or Thomas Edison's later? Absolutely not. What was important was learning how to write scripts, the idea of non-linearity when you actually shot the I can't get that word out. When you actually shot it, all the techniques that came up with special effects. Like if you see some of the background film that was shot for the Lumiere brothers movie of Going to the Moon, it was kind of like a really short version of Jules Verne's thing. It's pretty amazing.
Oh yeah, they did some beautiful fades and superimpositions. It's gorgeous work.
Yeah, you know, and how they were able to mix dimensional sizes, things that were models versus real life. So all of those kinds of things, it won't make any difference. You know, the package that you learn them on, those skill sets will transfer over, and presumably the packages that come out of the Microsoft, Googles, and probably a whole bunch of startups that you know don't even exist yet, are going to be focused on making it very, very easy. Like there's a little app that I came across a few days ago from a company called Grib, Grib, and then I think 3D. And what they did was something really clever. You can actually just draw on a piece of paper, and their demo page when you go to it is mostly kids, just to illustrate, you know, that you don't have to have any training to be able to use this thing. And so you draw some image on a piece of paper, and then you point your cell phone camera at it, and then that immediately becomes something that you can manipulate in a 3D way. So you can loft it and turn it from that 2D thing to 3D, obviously change and distort the shapes, but it allows you to get started really quickly. And it begins to give a sense for what those interfaces will look like. Basically, there won't be explicit interfaces. And then this is a list if people are interested. Minecraft, Fortnite are obviously well-known game type environments. The Minecraft is a learning one. But they're all now 3D ray traced. So if you look at these things, there's a sense of what fully immersive 3D worlds look like. And it's also not a bad place to mine ideas for, okay, why start from scratch? I mean, these things have been around in some cases for decades, so it's definitely worth going and looking at what other people have learned. And nowhere is trying to think of what's the best description for nowhere?
It's a sort of a virtual meeting space technology, I would say. Very 3D in concept, not just visually, but sonically. I would say orally, but it's impossible to distinguish between orally and orally. So sonically, so you can walk towards and away from sounds, and things grow and fade in volume as you get closer and further. And you float around as an avatar of your face, basically, as I recall, which can bump into objects and stuff. So you have to be careful of what's in your surroundings. Things can be active, and tapping on them can do things in the space or take you places. Yeah, it's an interesting concept.
So it's kind of like a virtual cocktail party.
Yeah. I think the goal is to be able to host things like virtual cocktail parties as easily as things like, virtual board meetings. So natural language, this is definitely an area of, again, perpetual interest going back to the beginnings of computing practically, and the idea that we should just be able to talk to our computers and get them to do what we want. It's been a staple of science fiction since before computers even were really well codified. We're all familiar with it from Star Trek onwards in pop culture. That's Star Trek, the original show. But natural language processing has turned out again and again to be fiendishly difficult to implement in any useful way with limited resources for processing, limited storage, limited memory. And it's only in the last decade or so that it's really come into its own. And even there, it's still fraught with peril, as anybody who's had their Alexa do something they weren't expecting, or Siri, or any of the other assistants.
Well, it's interesting that you bring up the audio version of this, because I'm thinking we might want to actually pull out the Neuralink type things that we have in the IoT deck and move them over to the next gen interfaces, because the ultimate goal would be to get to the point where you simply think, and you don't have to explicitly vocalize anything. And imaging is the same thing, both from a prosthetic point of view, absolutely there for people that have lost vision totally, but also as a long-term goal for these visualizations to somehow be able to directly imprint onto either the optic nerve or the occipital lobes the visualizations, and not have to go through these intermediate steps where you're throwing images directly on an eye. And there is some work that's been done, most of it tied to actual mechanical prosthetics, things like artificial legs and arms, to be able to control those directly just by thinking. And there's also been some work that's almost a little bit scary, where people have put in MRI machines, and using deep learning technology, you can actually extract what they're visualizing. The little movies I've seen are very ghost-like. They're black and white and fairly ambiguous shapes, but you have a sense of what the people are imaging, and you're seeing it in real time. And some of the techniques that are being used for quadriplegics are getting very, very accurate. I think one of them was over 95% if they sub-vocalized words. And again, this was to be able to control systems. Game companies have been trying this for decades.
I was going to say, as another scale of time data point here, my first IT job as a programmer was working in a computer music studio where the guy in charge had developed a neural interface technology for controlling computers. And I was writing like a fast Fourier transform routine. But that was back in the 80s, the mid 80s, and yeah, it's not come as far as you might hope it would in the intervening decades.
No, what went wrong is it took forever to be able to get high enough resolution sensing technology to pick out what was happening at large numbers of neurons at the individual level. And then the math was completely unequal to making sense out of it. It's only when the deep learning networks became available that all of a sudden magic started happening, and
Yeah.
we saw, real progress. Like the actual encoding algorithm that the brain uses for audio has been decoded, and they've done similar work for the optical system. Now it's still, this is all lab research, it hasn't been translated into actual prosthetics, but it would be surprising if by the end of the decade we don't have more or less full control over exoskeleton type prosthetics for people that have been injured, and that assumes also that we're unable to regrow the spinal cord nerves, and there's a lot of progress going on in that end too.
Yeah.
And hopefully for visually impaired or for people whose eyes have been damaged, that we would be able to eliminate the need for external devices and be able to imprint the signals directly.
Artificial eyes.
Yeah, yeah. Not around the corner, but because most of the things that you see now, they're arrays that are being surgically implanted on top of the occipital lobes.
Yeah.
And so there's a limit on the resolution of what can be shown. Much of it right now is at the point where people could read, and some of the highest resolution ones, they can make out rough objects. But the end goal is definitely to not have to do that, to be able to transmit the signals using the same encoding that our biological systems do. Figure out how to recode what's coming out of the imagers, and then send that directly either along the optic nerve if it's still intact, because some diseases destroy that, and so that's not even around anymore. And so the fallback is to be able to imprint it directly on the occipital, the visual centers of the brain. But it's pretty amazing the pace that things are going at. And here we've got some additional links for people to go and look at.
I'm just going to leave this up. Folks who are interested in following up on these can pull it up in the replay and see them all in all their glory. But that actually is bringing us to the Q&A portion of the show. And I will encourage anybody who has not yet submitted a question, but they've got a question they want answered, please to do so. And of course, before we launch into Q&A, everybody should make sure and check out any links in the attachments tab that they have not yet checked out. There should be links there to register for upcoming episodes in this emerging technology series, as well as links to our our LinkedIn profiles, and a short survey you can take to connect with us if you want to be a part of our research, or maybe become a client. So let's get to some questions and hopefully some answers. Question one is, I'll just go ahead and interpolate, longtime listener, first-time caller. I was on the IoT session. Will the glasses or such be able to run on parasitic power? So that's what I was asking about earlier.
So the glasses are mostly relying on very small batteries that are inside the temple. Parasitic power, you can't get enough of it at this point to drive something like the projectors that are in the glasses. So the contact lenses, the answer is definitely yes. But for the glasses, no. They're either going to be wired or they're going to have batteries in them.
All right, good. Just drop something in the tab if you want to follow up on that. Next question. How long do you think it will take to go from focused voice control for a specific kind of job to general voice control? So it's that natural language question, really.
Yeah. So the reason I'm giving some thought to that one is the thing that slows down natural language processing is context, right? The ability for the systems to accurately detect what you're saying in terms of the sounds being translated into words is amazingly good. I mean, anybody that's got Alexa or Google Nest or any of those things, can see. And the same thing, like the automated transcription services are surprisingly good too. Not 100%, not as good as a human, but still very, very good. So that's not where the problem is. The problem is context. So the moment you want to try and be able to do the general kind of questions that you see in science fiction computers, that's where you run into the wall. So if it's for a specific field, right, it's easy to create the content. Well, I'm not going to say easy, but it's possible to create the context for those things. But if the example is you just want to be able to walk down the street and ask a general question, right, that's more complicated than inputting to, say, one of the mapping systems, how do I get from where I am now to there? You need some form of general artificial intelligence sitting behind it, because it's really not about the language processing anymore at that point. Now, the GPT-3 and some other clones, and I think the Chinese made one that had twice the number of data points in it that GPT-3 does, and that one's already enormous, like 3 billion plus. And data points in this sense is simply the number of words. So it's just a fancy way for saying how many words were input into this thing. But there were odd things that popped out of GPT-3. Like it began to acquire a certain amount of context just from shoveling, an absolutely enormous amount of data into it. So the question that's kind of interesting is there anything more than 3 billion words? Because as far as I know, they found everything they could get their hands on in the English language and shoveled it into this thing. And then that's one of the reasons why it can duplicate people's styles fairly easily. It did somehow, in the background, form generalized models and then be able to do what they call zero or single example training from just a few samples of a person's handwriting to be able to write in the same style as that person. In fact, that was one of the original scary things. Oops, we're overrunning, I guess so.
Which brings me to, sorry about that, Marc. We had a couple more questions. We'll see if we can't get answers back to folks otherwise. But that's all we have time for now. Marc, thanks so much. And everyone who's attended, please, thank you very much for your time and for the great questions. The replay should be up in our channel shortly. If you found it valuable, please share it with your colleagues, and do please take a moment to rate the webinar. It's much appreciated. And check out things in the attachments tab. Thanks so much for joining us today. We look forward to having you join us again soon.
Thank you, John, and thank you everybody who joined in. Hope you enjoyed it and learned something.
Bye all.
Bye. Have a great day.